Hello, and welcome back to Geometry. Today we're going to talk about 4.1 applying triangle sum properties and 4.2 applying congruence and triangles. First, we're going to talk about 4.1 applying triangle sum properties. A triangle is a polygon with three sides. When the sides of the polygon are extended, then we know that the interior angles are the angles on the inside, and the exterior angles will be the angles that are formed by the exterior of the polygon and the exterior line, which are drawn in blue. Triangle sum theorem states that the sum of the measures of the interior angles is always 180 degrees, while the triangle sum corollary states that the sum of the measures of the acute angles in a right triangle is always 90 degrees. In this example, the front face of a wheelchair ramp forms a right triangle. The measure of one acute angle of the triangle is 8 times the measure of the other. Find the measure of each acute angle. So in the problems like this, I would suggest that you draw your triangle. Here we have a right triangle, and we put in the values of x and 8x for the acute angles. Pause the video now to solve for the missing angles. So you can use the triangle sum corollary and write the equation 8x plus x plus 90 equals 180. And when you solve for x, you get that x is equal to 10. There's another method where you could have used the triangle sum corollary, which means that since we were given a right triangle, we could have said 8x plus x, which are my two acute angles, is equal to 90 degrees. So 9x is equal to 90, therefore x is also equal to 10. To find the measure of the angles, we're going to substitute the value of x into each of those expressions. So I have the top left angle is 8 degrees, while the bottom right angle is 10 degrees. The exterior angle theorem states that the measure of the exterior angle of any triangle is equal to the sum of the measure of the two non-adjacent interior angles. Recall that adjacent means next to. So angle 4 is my exterior angle, and the adjacent angle is angle 1. Therefore, the two non-adjacent angles will have to be 2 and 3. So I can write the equation, the measure of angle 4 is equal to the measure of angle 2 plus the measure of angle 3. Angle 2 and angle 3 are the two non-adjacent angles to angle 4. In this example, we need to find the value of x. In this triangle, or in this diagram, I'm given one exterior angle, which is 3x minus 22, and two non-adjacent angles, x and 80. I would use the triangle sum or the exterior angles theorem to solve for this. Pause the video now to try and set up your equation and solve for the missing angle. So I would use the exterior angles theorem, which states that the exterior angle, which is 3x minus 22, is equal to the sum of the two non-adjacent angles, which are x and 80. So x plus 80 is equal to 3x minus 22. I would solve for the value of x, and x is equal to 51 degrees. And since in this problem I was only looking for the value of x, I can stop the process here. Classifying triangles can be done in two different ways. They can be classified by their sides or by their angles. Sometimes we classify them by both. In this diagram, I have three triangles, one with no congruent sides, one with two congruent sides, and one with three congruent sides. To classify these triangles by their name or by their sides, the first one with no congruent sides, I would call that scalene triangle, which means no equal sides. The middle triangle is an isosceles triangle, or it has at least two equal sides. This last triangle is what we call an equilateral triangle, 3 equal sides. An equilateral triangle is also an isosceles triangle because isosceles triangles have at least 2 congruent sides, but it can have more. If we're going to classify triangles by its angles, there are 4 different names we could use. If I have 4 acute, looking at the triangle in the top left, I have 3 acute angles. If I have a triangle with 3 acute angles, I can classify it as an acute triangle. On the bottom left, I have a triangle with 1 obtuse angle and 2 acute angles. This is what we classify as an obtuse triangle. It has 1 obtuse angle. On the top right, I have a triangle with 1 right angle and 2 acute angles. This is what we call a right triangle. The square in the lower left corner of this right triangle is how we denote that it has a right angle. In the triangle on the bottom right, it has 3 congruent angles. This is what we call an equal angular triangle. It has 3 equal angles. Equal angular triangles are also known as acute triangles. Pause the video now to try and identify these triangles by its sides and angles. The top left corner, I have a triangle that is isosceles right or right isosceles. Right denotes the angle and isosceles denotes the types of sides. In the middle of the page, I have a triangle with 2 congruent sides and what appear to be 3 acute angles. This is what I would call an acute isosceles triangle. In the top right, I have a triangle that appears to have an obtuse angle and 2 acute angles. I would call this obtuse scalene triangle. I'm calling this scalene because none of these sides are congruent to each other. In 4.2, we're going to apply congruence and triangles. Geometric figures are congruent if they have exactly the same size and shape. That means the corresponding sides have to be equal and the corresponding angles have to be equal. Based on appearance, we're going to look at these 2 diagrams. I have 2 triangles on the upper left, and we have 2 triangles on the lower right. We're going to decide if these 2 triangles are congruent. This first set of triangles in the upper left corner are congruent, while the 2 on the lower right are not congruent. They are not the same size. Corresponding parts are the sides and angles that are in the same position as each other. So recall when we were talking about corresponding angles in parallel lines. While congruent figures are figures that have corresponding sides and angles that are all congruent. In this diagram, I have 2 triangles. I am going to identify the corresponding sides and the corresponding angles. First, let's look at the angles. The angles are usually the easiest to identify. I notice that angle K and angle B are congruent to each other, while angle D and angle A are congruent, and angle J and angle C are congruent to each other. So based on those congruence of the angles, we're going to look at the corresponding sides. I am identifying that line segment KA and line segment BD are congruent to each other, while JA and DC are corresponding with each other. Notice how they are in between line segment JA and line segment DC are in between the right angle and the smaller of the acute angles, J and C. So that's why I'm corresponding those two sides together. And the last line segment would be line segment JK and BC. To identify the congruent triangles, order does matter when labeling these figures. So I can label it triangle JAK is congruent to triangle CDB. Notice that J is in the first position and is congruent to angle C, which is also in the first position. Angle A is congruent to angle D, and they are located in the second position, while angle K and angle B are also congruent to each other, but they were located at the end of the congruent statement. This is not the only way that we can name these triangles. We could have used any of these two names where I just rearranged the angle that went first. So either A and angle D went first, then angle K and angle B, and finally J and C. But I could have also changed the order a little bit more. All three of these are valid names for these two congruent triangles. We have three additional names for these congruent triangles. We could have gone in reverse order. Rather than going from J to A, I could have gone from J to K and gone in reverse order. So here I have angle K is congruent to angle B, angle A is congruent to angle D, and angle J is congruent to angle C. Those are still in correct order. They're just using a different, I'm just going clockwise rather than counterclockwise. In this example, name the corresponding parts of the triangles of triangle GRT is congruent to triangle MBH. So pause the video now to name the corresponding parts. So here I'm going to identify the angles first. I have angles G is congruent to angle M. I know this because G and M are in the first position of the name of the triangle. I know that angle R and angle B are congruent to each other because they are also in the first position of the triangle. And angle T and angle H are congruent to each other because they are the third letter of the name of the congruent triangles. I'm going to go ahead and name the sides. So because I'm given just the name of these two triangles, triangle GRT is congruent to triangle MBH, I can actually use this naming system to help me name the congruent sides. So here I can see that GR is the first two letters of the first triangle, and MB are the first two letters of the second triangle. So those two line segments must be congruent to each other. While the line segment RT and BH are the last two letters of their respective triangles, they must be congruent to each other as well. And the final line segment that must be congruent will be GT and MH. Notice how I took the letter from the first letter of the triangle and the last letter of the triangle to create the last line segment. You could have also have drawn the triangles to help you identify the corresponding parts. I personally find that when I'm given the name of the triangle, it's actually easier for me. But you are welcome to do whatever you need to do. So how else could we name this same congruent triangle? So there are 5 additional names for these two congruent triangles. Pause the video now to try and name those 5 different triangles. These are the 5 additional names for the congruent triangles, and you can see that I just changed the order. I either went forwards or backwards. In this example, I am given that triangle PSW is congruent to triangle QZN. Pause the video now to try and solve for the values of X, and y. So first, I've noticed that angle P and Q are congruent to each other. That means that they have to equal each other as well. So I'm going to use the equation 50 equals 5x plus 10, and x is equal to 8. Next, I decided to solve for angle Z. Angle S and angle Z are congruent to each other. Notice how they are the middle letters of both of their triangles. So 70 is equal to the measure of angle Z. Lastly, I need to find Y. So the measure of angle W is unknown to me. I know that angle W and angle N are congruent to each other, but I don't know the value of either one of them. What I'm going to do is use the triangle sum theorem, which we talked about at the beginning of this video, and use that to help us find the measure of angle W. So 180 is equal to the measure of angle S plus the measure of angle P plus the measure of angle W. I'm going to substitute in the values of angle S and angle P to solve for the angle W. 180 is equal to 70 plus 50 plus the measure of angle W. I'm going to combine my like terms and subtract it from the right-hand side to the left-hand side, and I get 60 is equal to the measure of angle W. So 6 degrees represents the angle of W and the angle of N. I can use this fact that angle W is equal to 60 degrees and write the equation 2y is equal to the measure of angle W. Next, I'm going to substitute in the measure of 60 in for the measure of angle W, which is what we found just moments ago. So 2y equals 60 and y is equal to 30. Here we found the measure of all of our variables. Another theorem that we're going to talk about is the third angles theorem. If two angles of one triangle are congruent to another triangle, to another two angles of its second triangle, then the third angles of both of those triangles must be congruent to each other. So, since we know angle A is congruent to angle E, and angle C is congruent to angle D in triangles ABC and triangles EFD, then we can conclude that angle B is congruent to angle F. Finally, some properties that you need to know for congruent triangles are the reflexive property of congruent triangles states that if triangle ABC is congruent to triangle ABC, then triangle ABC is congruent to ABC. So there's no change in that. It's the same forwards and backwards. While the symmetric property of congruent triangles states that if triangle ABC is congruent to triangle XYZ, then triangle XYZ is congruent to triangle ABC. So you can flip the order. The transitive property of congruent triangles states that if triangle ABC is congruent to triangle XYZ and triangle XYZ is congruent to triangle MNO, notice how triangle XYZ is the middle term and is the connecting term. We can conclude that triangle ABC is congruent to triangle MNO as well. If you have any questions about what we've covered in class in this lesson, please make sure that you ask them in class when we next meet. Have a great day.